Hello IB. What we want to do with this section, 11C, is where we want to start doing algebra using trig expressions. So far we've seen two sort of relationships involving trig expressions, and we can refer to those as identities because they are another way of writing the same trig expression. The first one was, we know that tan x or tan theta is the same as sine x over cos x. And we saw that coming out in the unit circle. So that's the first identity we've seen. And another one, if you think about it, can you remember? It was sine squared x. That's the same as sine x all squared plus cos squared x. Let's make that 2 look a bit better. Equals 1. So there's two expressions or identities that we can use to simplify other expressions. So we want to look at different ways of simplifying expressions. This is an expression because it doesn't equal anything. Here we've got 2 sine x minus 5 sine x. So if we think about what we've got here, think of sine x as just one term, and we've got 2 of them minus 5 of them. So just as if we had 2a minus 5a, that basic algebra, then we can say 2 sine x minus 5 sine x is the same as minus 3 sine x. In this one here, we've got 3 sine squared x plus 3 cos squared x. If we want to simplify that, hopefully already you may recognize we have a common factor. So let's factorize out the 3, and we come up with 3 sine squared x plus cos squared x. So once you know the two identities we have above, you might start going, oh, I can see a sine squared x cos squared x in this relationship, and I know that that equals 1. So here we can go, great, now we've got sine squared x plus cos squared x. We know that equals 1. So that's the same as 3 times 1, which is equal to 3. So now we've made that expression much simpler, instead of having all those sine squared x's and cos squared x's. In this one here, where we have cos theta minus sine theta all squared. So remember, if we've got two terms, a binomial squared, do you remember your expansion for a binomial? If we have a minus b all squared, what does that expand to? Hopefully you remember it from years 9 and 10, or else from binomial theorem. So we've got a squared minus 2ab plus b squared. So let's do the same thing over here. We've got cos square the first term, so we get cos squared theta minus 2 cos theta sine theta. That's the AB part of it. Now we square the last term. Minus sine times minus sine gives plus sine squared theta. And hopefully you're going, oh, gee, I can recognize this expression again. Here we have a cos squared theta plus a sine squared theta. So that way we can put those two together and we get 1 minus 2 cos theta sine theta. Alright, so we've got that simpler now by expanding the brackets. So every time, expand it, see what expressions you can simplify using those identities. Here's another one, tan squared x minus 3 tan x plus 2. What we're wanting to do in this is factorize. So instead of expanding brackets, we want to see, can we factorize these? So think of your tan x as just one term that's being squared. So that could be like t for tan, t squared minus 3t plus 2. So going back to your factorising of quadratics, so now we're tying quadratics into trig. So this one, how does that factorise? What multiplies to make plus 2 adds to make minus 3? Let's go back to red. That one you should be able to factorise easily into t minus 2, t minus 1. So that means tan x is t. So we've got tan x minus 2. Would help if I put the x in with a eraser. Try again. On blue. So tan x minus 2, tan x minus 1. So now that's factorised. In this one, we want to simplify this expression and see if we can make it simpler. So if we look at this one, we've got a 1 plus cos theta on the denominator, 2 minus 2 cos squared theta on the numerator. Now, let's pull out the 2's because I can see we've got a common factor there. So let's see what we get if we pull out 2, 1 minus cos squared theta all over 1 plus cos theta. All right, we certainly can't just cancel those because they're not being multiplied. We might be able to go 1 minus cos squared theta equals sine squared theta. So that's the same as using this Pythagorean relationship again over here. But if we turn that into sine squared theta, that doesn't really help us cancel anything out. It doesn't necessarily become simpler. You might also be able to recognise this as an a squared minus b squared. It's a difference of squares. So that becomes a minus b, a plus b. So again, we're bringing back in all that factorising of quadratics. You're going to tie your quadratics into every section. So let's now expand this using the difference of squares. So we've got 2, 1 minus cos theta times 1 plus cos theta all over 1 plus cos theta. Fantastic. We've got what we were looking for, a common factor. All right, so think of this as just one whole thing, and that all cancels with all of that. So that's what we wanted. So that cancels, and we're now left with 2 brackets 1 minus cos theta. And we can expand that. A bit more space to 2 minus cos theta. All right, so we're going to leave it there. We've got another problem that we can do in class, but that's a good start to get you thinking about how we can simplify things using the identities we had from earlier in the chapter 8 and using old rules from quadratics. Thanks for listening. We'll see you in class. Bye for now.